Hello, my name is Augusto Gonçalves and I work for the Developer Technical Services Group at Autodesk based in São Paulo, Brazil. Welcome to this presentation where I will present an introduction to the programming the .NET Revit API. Here is a quick Meet the Presenter slide. Next time we see each other at a conference or meeting, please come up to chat. I'm always glad to meet developers. There are three versions of the Revit: Architecture, Structure, and MEP. I'm assuming you know how to use the Revit product and the main differences of these versions. Most of the API is shared across all versions, but there are some specific features available only if we are running the specific product. The API was written in .NET and you can use it from any .NET programming language. Here we are going to use C#. The SDK, Software Development Kit, contains very interesting information. If you don't have it yet, I strongly recommend you that you download it from www.autodesk.com/developer. Once you download it, you should definitely take a look at the Revit Developer's Guide, which is a book-style tutorial about the API. The API reference, which contains a list of all API classes available, and the samples folder, which contains several samples. We recommend that you look at the following samples: Revit Commands, Fire Rating, Viewers Element Viewer, Create Beams Columns Braces. Let's make a quick start creating a classic reload word sample, where we will be able to configure the development environment, create a .addin file at Revit \addin folder, and choose the transaction and regeneration modes. At Visual Studio, let's create a file New Project, select the location and the project name. We also have to choose the option Class Library here and just hit OK. Then we need to add reference to Revit References. So select Reference, right click and Add Reference. Let's go to the Revit Install folder. I'm assuming the default folder location for Revit 2011. At the Program folder, here we need the Revit API.dll files. So let's filter using the star symbol. And then we have Revit API, which contains access to the API, and the Revit API UI, which contains access to the API for user interface. Okay. It's very important to mark those references as properties copy local equals false. Then we are done. To use the API, we need some namespaces at our code. Let's add some specific namespaces for Revit API. Autodesk.revit.ui, Autodesk.revit.db, and Autodesk.revit.attributes, and finally Autodesk.revit.ui.selection. In Revit API, each class represents an external command. So let's mark how this class should be treated as an external command inside Revit. We have to add some attributes to this class. In this case, we are going to use the transaction attribute using the transaction mode manual. So let's use it automatic for this time. And also the regeneration mode as manual. To implement a command, we must change this class to inherit for another class on the Revit API. In this case, let's use external command. Once we have that, Visual Studio shows the option to implement the required methods. So let's select this option and mark implement interface external command. We don't need this region, this is just for visual, and this region here. As we are going to implement this command now, let's remove this exception from here. Just to make it more visible, I'm going to create some new lines here. Okay. Now, as this is just a simple hello world, let's just show a message using a task dialog. This is an internal task dialog from Revit. It's more like a simple message box. And a title, hello world. Okay, every command inside Revit must return something. So for now, let's return succeeded. Okay, now we have a command. To make this code work as a command inside Revit, we must register this class. So let's build it. Okay, we have the location of the DLL here. And we need to register inside Revit. To do so, let's go to the following folder: app data /Revit Autodesk /Revit /addons /2011. At this location, we must create a .addon file. So let's use new text document and change it for hello world.addon. Now we can edit this file with Notepad, for example. This .addon file is an XML file that should contain the following marks: the assembly, which contains the location of the DLL, and addon ID, which is just a registration name for this addon, and the full class, which is the class name of our addon, and a text, which is the message showed for the user. Let's replace with that. This is the location of the DLL. This is the registration name, a GUID. This is the class name. In our case, if we go back to our project, we have Revit Dev TV class 1. So we have the same here, Revit Dev TV class 1, and a message. Let's save this file and start Revit. Inside Revit, we must create a new document to use it. And then we have addons, external tools, hello Revit. One easier way to create this project is using the template available as part of this DevTV. You can also download the template at the blog I'm going to mention at the end of this presentation. So once you have the template installed, just go to File, New Project, and select Revit Architecture 2011 Addon. Change the name like we did before. and this template will automatically create for us the command class with some basic implementation. It's empty, but it's a basic implementation with the required namespaces here, and also creates the .addin file. Here's the .addin file. One interesting point of this template is once we build the project, it automatically copies the file .addin to the proper location on the Revit /addins/2011 folder, which saves us some time. It also removes this file once we select the clean solution. It will remove the file from the Revit folder. It's not here. Once we build, the file is here. During development time, you can save yourself a lot of time using the Add-in Manager for Revit tool. This tool is available as part of the SDK and allows you to easily create new .addin files by selecting the assembly and the external command you want to run, and even run an external command without need to create a new .addin file, meaning without need to restart Revit. We will not demonstrate how to use it here, but you should definitely use it on your development. Any external command receives one input, command data, and two outputs, message and elements. The command data allows access to all data we need in our command. There are two main properties, application and view. The first contains the active document with used methods and properties, such as elements and selection properties, and geometry and family related methods. The second view contains graphic and textual information, such as plans and schedules. Bottom line, we will use the command data in virtually all commands. If the command return failed, then Revit will display the message parameter with the elements appended to the elements parameter. Now let's write some code. I will show you how to access the current selection, iterate through each element and show its type and parameter. We are going to use the project created with the template. So let's start with the UI application. UI app equals command data dot application. Let's also access the UI document UI app dot active UI document. Now let's get the selection cell equals UI doc dot selection. Now we can do a for each element in the selection with for each element in the selection. Selection.elements, and let's create a string message with some information about these elements. String element information equals string.format name and category. Element dot name, element dot category dot name. Finally, show the message. Task dialog dot show element information, element information. It's very simple. We're going to select something on the screen and then run this command. Let's build our project and mark a breakpoint here, hit F9, or we can also click on this gray area here and then go to debug, start debugging. Let's create a new project, draw something on the screen and select it and go to add-ins, command Revit API. We can see our code working now, and you can press F10 to run line by line, get the selection for each element inside the selection. Let's format a message and show this message. The name is generic 200 mm and the category is walls. The Revit Lookup Analysis tool is a very important and powerful tool. It allows us to inspect properties of the database, the current selection, and the application. Additionally, there is a set of test routines which also are good for learning Revit API features. Let's take a look. This tool is part of the SDK, so you have to download the SDK and go to Revit Lookup and get the .add file, copy it to the Revit folder and edit properly using the correct location of the DLL. Once you have that, you can go to Revit, draw something on the screen, for example, select it, go to Add-ins, Revit Lookup, and select, for example, Snoop Current Selection. This will show information about this selection on the screen. In this case, generic 200 mm. This is the element ID, and there is a lot of information here. All this information is accessible through the API. We can also inspect the entire database. Go into SnoopDB, go, for example, to wall, and see our wall here. We can also inspect the application and see information about the application. Here is a motivation for our next topic. This is the entity share of a simple database. Note that even on a small model like this little house, we have more than 2000 elements. Now, if you want to collect information about the project, we want some way to filter these entities instead of iterate through them all. Using the filtered element collector object, we can instantiate our filters. Usually, we first create a filter and add some criteria, such as class and category. Finally, we use the resultant filter iterator. The iterator can be used in a for each loop, which gives access to the filtered elements. Let's see a demonstration of filters. Going back to our project, the first step is access the document, db document. So document doc equals UI doc dot document. Then create a filtered element collector object. Filtered element collector. Let's filter all the doors inside this project. Doors equals new filtered element collector, and this constructor requires the document. Let's pass the document. Now we can add some criteria such as doors dot of class. Remember that a door is a family instance, so we need to use type of family instance. But this is not enough. We want to filter all family instances of a specific category. In this case, doors dot of category, built-in category, OST doors. Okay, now we have a filter configured for all family instances of category doors. Run through the collection for each family instance door in doors. Create a string with information about the door. In this case, let's use a string builder. You notice that this is not Visual Studio is not recognizing this class, but show us this option here under the object type. So we just select and use the option to import the required namespace, in this case system.text. This is a very interesting feature of Visual Studio. Once we click here, Visual Studio will create a new line on the top of our file with the required using. Door information equals new string builder. Door information dot append. In this case, let's use append formatted. Pass creating the name door dot name and show the information. Task dialog dot show door information. We're going to add more lines on this code later to string, because this is a string builder. So let's mark a breakpoint here and unmark the breakpoint here. Let's skip that part before. Let's go straight to this part here and go to debug, start debugging. Create a new project, create a wall, and add some doors, and then go to our command and run it. Document, create the collector of family instance category doors. For each door, in this case we have 2 doors, the name and show a message. Again, for the next door, show the message and go to the end of the command. We don't have any other door, finish the command. In Revit, we have a mechanism to access and edit the collection of built-in parameters of each element. Each parameter has its own properties, such as name, storage type, and value. We can also use the Revit built-in parameter enumeration to access them. Also, we have shared parameters, which are external text file containing parameter specification. I just mention it here because they are very useful to store additional information on the elements, but I will not cover it deeper, so please refer to the chapter Shared Parameters of the Developer's Guide for more information. The fire rating sample in the SDK will be a good example to learn how to use shared parameters. Let's see a demonstration of parameters on our project. Going back to Visual Studio, let's access the collection of parameters. In this case, let's use for each parameter param in the door dot parameters. So we have a collection of parameters of this element, door. The parameter name door info dot append format, new line parameter, and its name. Parameter dot definition dot name. To access the parameter value, we have an issue that is the storage type. So we cannot simply say parameter value dot toString. We must get the type and then convert for each type a specific string. Get the parameter type. Let's use a switch param.storage type, and we have a lot of options here. For example, string. So door information dot append param dot as string, or we have some difference such as double door information dot append param as double. But this is just a double, this is not a string, so we need to convert to a string. And we also need to do the other types, element ID, integer, and any other. But let's leave it as a homework. You can try it later. Door information append to do homework. Break. Just to make it more visible, let's add a value here, just to say parameter name and then the value, and we're going to treat two cases, as string, as double. Let's mark a breakpoint here and unmark the breakpoint here, and press F5 or simple start debugging. Like before, create a wall to place one door and go to our command Revit DevTV. and we have the parameter. Each element can contain a lot of parameters. So let's go to the first parameter. The name is finish. The storage type is a string. And the next parameter, the name is frame material, and just keep going. I'm going to run through the code and go to the end of the code. So we have an element name 0915, etc., and parameter name finish, the value it's empty. Parameter name frame material, it's also empty but it's a string. Double string empty. One that we are not working right now, homework, a double value, another one as homework, and another one as homework. We can also see the same type of information if we select the element and go to the properties, and we can type something, for example, at finish, testing here, and then run our command again. I'm going to unmark this breakpoint here and run through the code, and we see the parameter name finish, the value is testing here. Now that you felt the taste of the Revit.net API, I want to point out some extra resources that you might be interested. The first one is that you can find samples and detailed documentation inside the SDK package, such as the Developer's Guide. Now, my colleague Jeremy Temek published weekly articles about the Revit API at his blog, Debugging Coder. Next, we have the Developer Center, where you find a good overview of all API technology that we support, and also, if you are interested, you will find some free .NET training material for you to work through. Then, of course, we have the various Autodesk discussion groups for you to check. If you need training, then please check our API training schedule accessed via the autodesk.com/API training. At this API training website, you can also find many webcasts and specific topics, such as family MEP and structure APIs. Finally, if you are interested in joining our Autodesk Developer Network program, then please take a look at autodesk.com/joinadn, where you can find out about all the benefits of the ADN membership has to offer. That's all for today. Thank you for your time with the Revit.net API.